Welcome to 4.7. We're going to be looking at kind of combining all the order operations with fractions and also looking at complex fractions. And don't worry, complex fractions, they're not that tough at all. It's actually something that we've already done. It's really just division of fractions. So you'll see here in just a second. So the order of operations, just a quick reminder. Remember, we do everything that's inside the grouping symbol, so parentheses, brackets. If there's a fraction bar, we do everything that's above or below the fraction bar before we do the division. Then step 2, we evaluate any exponents. Step 3, we do all the multiplication and division, left to right. And then we do all the addition and subtraction, left to right. So, with that in mind, let's have a look at this problem. So let's go ahead and read this so that we know what it's asking. It's 5 plus 2.5 times 3 2/3. So there's nothing to do inside, right? Here it is, inside. There's nothing to do inside the grouping symbols, right? 2.5, that's as simple as it gets. 3 2/3, that's as simple as it gets. So then the next step is exponents. There's none of those. So now we're on to multiplication and division. We do have some multiplication right here. So we got to do that first. So it's going to be 5 plus. Now, how do we multiply mixed numbers? We have to change them into improper fractions. So 2.5. 2 times 2 is 4 plus 1 is 5. So 5 halves times 3 times 3 is 9 plus 2 is 11 thirds. 5 times 5 times 11 is 55. 2 times 3 is 6. So now we have that. So now probably the easiest thing to do here at this point is to turn our whole number into a fraction with a denominator of 6. So what we could do is, we could remember that 5, let's go over here for a second, 5 is 5 over 1. And if I want that to have a denominator of 6, I would have to multiply the 1 by 6. So I'd have to multiply the top by 6. 5 times 6 is 30. Oh, so 30/6. Oh yeah, sure, because 30 divided by 6 is 5. So 30/6 is the same as 5. So instead of 5, I can replace it with 30/6 plus 55/6. And that would be 85/6. Now I could leave it like this. This is a correct answer, but since I got my information, my initial problem, in mixed numbers, I really should get a mixed number. So I'm going to go ahead and divide. 6 will go into 8 once, with 2 left over, and then we bring down our 5. 6 will go into 25 4 times, because 4 6s is 24, with 1 left over, so 1/6 left over. So this is also a good answer, and this is actually probably the preferred answer. You'll get full credit for both, but you need to know how to turn improper fractions into mixed numbers for when you need to, such as word problems. You absolutely have to turn it back into a mixed number so that it makes sense typically in the context of the problem. Now let's talk about complex fractions. What is a complex fraction? Well, a complex fraction is just the division of two fractions. So let's have a look at this problem. 3/4 divided by 5/6. Now it's a little hard to tell, but this fraction bar here is a little thicker, so I drew my fraction bar a little wider to represent that. So that's what we call the primary operator. And so really the way you want to think about this This is the division symbol, right? This, where this is a fraction bar, and these little dots are placeholder for numerator and denominator. What's our numerator? 3/4. What's our denominator? 5/6. And so whenever we have a complex fraction, it's really just division of two fractions. We're going to write them side by side. And let me move this out of the way here. There we go. So now we've written the primary operator as a division symbol. Now, instead of dividing fractions, what should we do? We should multiply by the reciprocal of the second fraction. So I'll turn this division to multiplication, and I'll flip the second fraction. And now I can multiply straight across. So that's 3 times 6 over 4 times 5. Now, because 4 and 6 are both even, I think I'm going to have some reducing to do. So 18 and 20 are both divisible by 2. All right, 9/10. I think that's as good as it gets. So when I'm faced with a complex fraction, I simply want to write it as division, right, where the big fraction bar in the middle is the division symbol, and then recognize that division of fractions is really related to multiplication by the reciprocal. So sometimes we have a complex fraction and we have to do some work inside of it before we can do that. So here's an example. 3 plus 1/2 over 2 minus 3/4. So up top, 3 plus 1/2 is 3.5. And that's pretty straightforward. But 2 minus 3/4, not as straightforward. So 2, remember, can be written as 2 over 1. And 2 over 1, if I want that to be in fourths, I'd have to multiply top and bottom by 4. So that could be 8/4, right? That would be 2. That would still be a version of 2. And now I can actually do this math. 8/4 minus 3/4 is 5/4. Okay, great. So 5/4. That means I need to turn this top mixed number into an improper fraction. So 3 times 2. 3 times 2 is 6, plus the 1 is 7. So 7 over 2 over 5 over 4. So this is a complex fraction. And this is the main fraction bar. And so when I rewrite it, I want to write it as 7 over 2 divided by 5 over 4. So I'll rewrite that complex fraction as division of fractions, and then I'll recognize, oh, division of fractions is related to multiplying by the reciprocal. And then when you multiply, you can multiply straight across. And then you sometimes have to reduce. So 28 over 10, both are divisible by 2 because they're both even. So I'll just start with that and see where it gets me. Okay, so that's probably as reduced as the improper fraction gets. But because it is top heavy, I should turn it into a mixed number. So 5 goes into 14 2 whole times with 4 pieces left over. So it could also be 2 and 4/5. And since I started with some whole numbers and kind of a mixed number problem, this is the preferred answer. All right, so here's one where I am dividing. It's another complex fraction, but I've got to do some prep work before I can actually divide. So the first thing I want to do is turn all of these into improper fractions. So 10 times 3 is 30, plus the 1 is 31. So 31 thirds over 8 times 3 is 24, plus 2 is 26 thirds. So those are improper fractions. Now, this is the main operator, the big fraction bar, so I'm going to write it with the division symbol. So 31 thirds divided by 26 thirds. Now, instead of dividing, I'm going to multiply by the reciprocal. And then when I multiply, I can multiply straight across. Oh, and I can recognize that 3 divided by 3 will be 1. And so I have 31 over 26, and they are 5 apart, and I think 31 is a prime number, so they're not going to have anything in common. But because it's top heavy, I should turn this into an improper fraction. Or excuse me, it is an improper fraction. I should turn it into a mixed number. And so 26 will go into 31 one whole time with 5 left over. All right. So let's have a look at the review here. So what is a complex fraction? So hopefully it's not that complex anymore. It's just the division of fractions. So it's AKA fractions in fractions. So fractions inside of fractions. That is what division of fractions, complex fractions are. B, rewrite 5/6 divided by 1/3 as a multiplication problem. Okay, so first we have to write it as a division problem with the division symbol. And then we can multiply by the reciprocal. And you could write it like this, or you could have written the 3 as a whole number, and both would be acceptable. You don't have to do the math, I just want you to write it as a problem of multiplication. Okay, C, true or false? The rules for order of operations tell us to work inside parentheses first. True. They tell us to work inside grouping symbols. And parentheses are a kind of grouping symbol. Okay, true or false? We find the LCD, the lowest or least common denominator, when we add or subtract fractions, but not when we multiply them. Explain. So that is true. And the reason is because when we're multiplying, we can simply multiply straight across, but when we're adding and subtracting, they have to be in the same denomination in order for us to add and subtract their numerators. So when we multiply numerators and we multiply denominators. But when we add and subtract, we only add and subtract numerators if the denominators match. So hopefully that helps you answer the questions in this section, and reach out to me if it doesn't, and I'll see you in the next section, in the next chapter.